So in general, the volume of a solid is equal to the integral of the area of a slice multiplied by dy or dx. When dealing with solids of revolution, our slices were always discs or washers. In these new solids, the slices can be a number of different shapes, including squares, semicircles, triangles, rectangles, etc. So here in our first example, we want to find the volume of the solids described. Here, the base of the region is enclosed by the circle x squared plus y squared equals 1. So that means that we have a base here where our circle has a radius of 1. And now they said the cross sections are perpendicular to the x-axis and they are squares. So if I drew a cross section here perpendicular to the x-axis, it would be dx thick, and then it's shooting out here. Consider this shooting off of the page 3D, and that is a square. So remember, the area of a square is s squared. We have to figure out what does s equal. Well, if I look at this picture, here is my square. All sides are equal. Each side is s. So the s, the length of my side of my square, is this height here. Well, my upper function is y equals the square root of 1 minus x squared, and my lower function is y equals negative square root of 1 minus x squared. So s is upper minus a negative lower, or our side is 2 square root 1 minus x squared, because this becomes adding a positive. So now that I know the length of the side of my cross-section square, I can set up my integral. My area is the integral from, it's going to be negative 1 to 1, of my side, which is 2 square root 1 minus x squared dx. So now I can square that, and I'll have 4 multiplied by this quantity. Oh, and we're not looking for area, we're looking for volume, excuse me. So volume equals 4 times the integral from negative 1 to 1 of 1 minus x squared dx. So that's going to equal 4 multiplied by x minus x cubed over 3. Evaluate it from negative 1 to 1. So that's going to be 4 multiplied by 1 minus 1/3, subtracting negative 1 plus 1/3 units cubed. So our cross section was a square. The side of that square we found by doing upper minus lower. We plug it into the formula for the area of a triangle, area of a square, multiplied by dx, and calculate that integral.